Alright, hi everyone, welcome to my YouTube channel, City of Electrons. And in this video, we are going to talk about vector products. Of course, the previous ones, we've been talking about scalar, 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 scalar. Now, in this one, of course, vector product. And the idea of vector product is that when you carry out the operation of two vectors, the result you get is a vector. That is why it's called vector product. Okay, now I think previous videos we said something about when we try to define vector product and a scalar product, that the main difference, okay, under product of vectors, the main difference is that the product has multiplication. Okay, so if the product of two vectors, if the result, what you get is a scalar, then it's called scalar product. If it results in a scalar, it's a scalar product. Now, if it results in a vector, it's known as vector product. So vector product is what we are going to do today. Now, for the definition of vector product, the definition of vector product is this: the absolute value. Look at it. Vector product is defined as the absolute value of the product of the magnitude of the vectors and the sign of the smaller angle between the vectors, while the direction of the vectors is perpendicular to the plane in which the two vectors lie. Now, one key thing I want you to bear in mind is this guy, absolute value. Whenever the word absolute shows up, most times this should come to your mind, this sign. Okay, two parallel lines like this should come to your mind. So what is being said in the definition is that it is the absolute value of the product. That means you have them, A and B, multiplying themselves like this, and then what other thing do we have? The magnitude of the two vectors, yeah, and then the sine of the smaller angle. That means we have sine phi AB is the angle between A and B. So you have everything like this: A times B times sine AB, sine phi AB. Then you now put this sign, this sign representing absolute here and here. That's just it. Of course, this represents the unit vector, which is normal to the plane formed by the two vectors. When we say normal, we mean perpendicular or 90 degrees. Okay, that's what we mean. I'm going to talk about what we mean by normal under the properties of vector product. So don't worry about it, okay? Just be relaxed about it. Be relaxed about it. You are going to get it really, really easy. So all this definition, all this write up here, this definition is just, or it can be expressed mathematically as A cross B equals AB sine phi AB, or theta AB, whichever one you want to use. Whichever one you want to use. AB sine AB. Okay, of course this is the angle. Then okay, and then this is the unit vector, and of course it is normal to A and B. So under the properties of vector product, which I'm going to end with in this video, we are going to stop at the properties of vector product in this video. So now, to explain the properties of vector products, this is what I want you to picture. Okay, this is vector A and vector B, two vectors. What we are saying is that if we cross them like this, we are going to get another vector C and B. So the nature of this C means A. The nature of C means A B sine phi AB. Now, this normal is what I want to explain now. This normal means, it simply means, why do I have these guys here? That normal simply means that if we have A in this direction, we have B in this direction, that's not straight enough. If we have A in this direction, B in this direction, let's say if this is in let me make it like X, Y, and Z. So if this is in this direction, the next their result will be in another dimension, or direction I should say. Okay, a very good way to draw this would be like having a box. Okay, let me use this. I think this will be close enough, okay, to represent it. Yeah, now that is if we have vector A like this, and we now have vector B like this, vector C will be perpendicular. So you see that this one is in, let's say, the y-axis, this one is in the x-axis. The result, the cross product of these two will be in z-axis. Okay, that's what we mean by normal. So the result of these two is normal. You see that this guy, this, let me go closer, this is 90 degrees to this. So also our result must be 90 degrees to the cross product. That 90 degrees is what we mean by normal or perpendicular. Okay, that's clear enough. So with that being said, already that is one of the property of cross product or vector product. Yeah, vector product is also known as cross product because of the cross sign. Okay, also known as vector, also known as cross product. Oh boy. Now, with what I just explained, it is also a property of the vector product, which is where are you? I think I have it somewhere here. Yeah, that's the second property. It is always perpendicular to the plane of the two vectors, which I just explained. Okay, now let me read number one now, which is what? It is not commutative. Vector products are not commutative. What do we mean? A cross B, it is not the same as B cross A. Okay, it is not the same as B cross A. That is just like saying in the x direction and across the y direction, it will give you z. Okay, but y direction cross x direction, it will give you minus z. How do I know this? Or how come? Why do we have it like this? There is a rule. Look at this pattern. There's a pattern you have to bear in mind, which is quite easy. This is the pattern. X, let's have it like this. X, Y, Z. X, Y, Z. Now, if you go, let's take this. Good. If you go in this direction, it's positive. If you go in this direction, it's negative. What do I mean? A going like this, okay? X cross Y will give you Z. Okay? Z cross, oh good Jesus, Y cross Z will give you X. Are we seeing the pattern now? So this is for positive and this for negative. So but if we go this direction now, saying Y cross X, that will give you minus Z. Are you I hope you can see what we're talking about now. Okay, so it is not commutative. That means commutative just means that X cross Y equals something, and if you won't change the order, if you switch which one comes first, it must be the same. That's the meaning of commutative. But in this case, it is not commutative. Okay, so we'll still come back to this guy later on, like maybe in the next video or so, because they will help us to make some simplification of cross products. So just have this in mind. We'll come back. We may, but we'll come back to it later. So okay, so it is not commutative. I hope that's clear. Then it's always perpendicular. I've said that already. Then the vector product of two vectors, the vector product of two parallel vectors is always 0. Why? Oh boy, why? Now, if two vectors are parallel, now in this case here, look at this. In this case here, vector A, vector B, they are perpendicular. The angle between them is 90. That means the angle between them is 90, they are not parallel. But if they are parallel, you know parallel lines now, okay, lines that when extended they never meet. So if vector A and B are parallel, so what is the angle between them? Nothing. 0. They are in the same dimension or the same direction, okay, or the same xx or yy or z. There is no angle between them. Angle between them is 0. Now you can punch a calculator, or maybe just think about it. Sine 0 is what? 0. And if you plug 0 into this expression, into the formula, plug 0 here, okay, sine 0 is 0. Whatever the value of b and a is, if you multiply 0 by it, you have 0. That means the cross product of a and b will be what? 0. So that's why we have the third property, that the vector product of two parallel vectors is always 0, because sine 0 will give you 0, and multiplying all this, cross product equals 0. Okay? Fourth property, the vector product with itself is always 0. Brethren, this is like the third property. This is no, okay. The fourth is likened unto the third. When a vector crosses itself, just think about it. What is the angle between one vector and the same vector? It's just like that vector is, there's no angle between them. So the angle between a vector crossing its own self is 0 now, there's no angle. Of course, sine 0 is 0, which is likened, like that's why I said the fourth rule or the fourth property is likened onto the third property. The fifth, it is not associative. This, my friend, is likened onto the first. Not exactly, but close. Not exactly, but close. That is, if we have the idea of if we have A cross B cross C, okay, this is not the same. It is not the same. Oh, I have done something already. Let me just pack it and take it out. Okay, but this one, it is not the same as A cross B cross C. That means I will do the cross product of this one first before I cross it with C. It is not the same as if I do the cross product of B and C first before I cross the result with this. It is not the same. Okay, so it's just like the one we explained using the using this, something similar to that. Okay, so it's not the same. Okay, now it is distributive. Yeah, this one is agreed. Distributive. What do we mean by that? When we say it is distributive, okay, let me use this top side. This is what we mean by distributive. B plus C. That means you can spread this out as saying A go and cross B, then the result A go and cross C. Okay, this is what we mean by it is distributive. Okay, so the last one, the magnitude of the vector product represents the area bounded by the parallelogram formed by the two vectors and lines parallel to the vector. Again, what do we mean? This is what we mean here. Having vector A, I can use this one. Having vector A and vector B. If you extend this, look at vector B, right? This vector B. If you extend vector B further, like in the opposite side, and then vector A, you extend it further. So this is also A, okay, and this also, this diagram is also B. How this looks good. Let me take out this. Okay, hope this looks good. But I'm trying to draw a parallelogram. Hope this is manageable. Now, B, B, A, A. Now this forms the parallelogram. Now the parallelogram, now the area of this parallelogram is the same as the magnitude of A cross B. Bam. Okay, it's the same as the magnitude of A cross B. And you know, there is this interesting idea. If you cut the parallelogram into two, you have two equal triangles, one facing down, one facing up. This is my line. Let me try if I can make it a bit better here. So if you cut a parallelogram into two equal parts, diagonal line, you have triangle upwards, triangle downwards. So that means the area of a triangle can be determined using cross product. Just take half of the cross product, you get area of a triangle. Okay, but if you just take the magnitude, what did I just say? Half of the cross product, the magnitude of the cross product, yeah, that's what I should say. Okay, to give you the area of a triangle. But if you remove the half, it will just give you the area of a parallelogram formed by the two vectors. Okay, so those are the properties of a cross of vector product. It's the same thing as cross product. So in the next video, we are going to go further, consider two vectors A and B, and then simplify further in the cross product. But I hope this video is helpful. We just talked about the definition of vector product and then the properties of vector products. So like, share, subscribe, comment, and I'll see you in the next video. Thanks a lot for watching. Bye for now.